coordinate system. Okay, and that coordinate system is called the normal tangential coordinate system. And it can change, but tangent is always, this is moving in this particular velocity. Okay, so tangent is always tangent to the path in the direction of the velocity, and normal is always in towards the arc. It's not really a circular path for most of our problems, but in towards the concavity of the arc there. And we do that because, again, velocity and acceleration are typically written in that direction, or are a relationship of an equation in that direction. So, if you didn't like I and J and K, you're really not going to like this one. Okay? So, I and J are unit vectors. Okay, and we really should put a little hat over them. I always kind of get a little bit lazy here. So, our unit vectors in these directions are E sub t and E sub n. That's just the same as an I or a J or a K, but I'm not sure where the E came from, but I know where the T and the N came from, right? Tangent and normal. Okay. So when you see this, don't raise anything to the power of, what is E, 2.17? Okay. This E is different than the 2.17 E. It's just a unit vector. So don't multiply, for example, if you have 3 E sub t minus 6, actually it would have to always be plus 6 E sub n. You don't multiply the 3 or the 6 to anything. Just keep that E sub t and that E sub n in there. And then if you're adding things together, you add the E sub t's and you add the E sub n's, but you keep them separate. Unless you want the magnitude of it. So let's say our velocity was, what did we say this was? 3. And this velocity was 6. Okay. If you wanted to know the magnitude of it, the total velocity, then you just take the square root of the sum of the squares. So you just have to kind of keep moving your head so that it looks like it's straight. But it's all good. So we spend about 6 slides. This is why it has 86 slides or 68. We derive it, and it's a pretty hairy derivation. We have to relate everything, but basically it boils down to this A sub t and the A sub n. Sometimes you're probably used to seeing b squared over r because we're working in arcs rather than circular paths. The rho there is just the radius of curvature. So let's, oh no, I had another, well, we can do this now. I didn't realize I did have a projectile motion problem. So we'll work through that, and then I think we'll just have time to work through the circular motion here.